So coming back to the learning outcome for today, it will be based on guided and unguided media. So we will touch a bit on wired media communication and also wireless media communication. So these are the medium that needs to be used so that we able to do communication. Okay. But if you see on the widest type of media, means that although you have a medium of transfer, but basically you unable to see it with your bare eyes lah. But if you can scan on the background on the frequency band, you will see that different channel that have or available for this kind of transmission lah. Okay. So we will look into a few transmission media, and also we will also cover on the MAC addressing, okay, and ARP and so forth. Okay. So for transmission medium, we can classify it into two. Can be either guided media, twisted cable pair, coaxial cable, fiber optics. Okay. Whereas unguided media, where we will look into more about radio wave, microwave, and infrared lah. Okay. So for transmission media, as I mentioned, that we can have a physical transmission media, can be either your fiber optics, can be either your coaxial cable, can be either your what they call it, coaxial cable and so forth. Okay, so these are located in our TCP/IP layer, which is located on the physical layer. Okay, and it is directly controlled by the physical layer, whereas the medium itself, okay, it can be mentioned as a layer zero lah. The physical layer is on the bottom of your TCP/IP, whereas the medium will say that this is the layer zero. So as you can see here, okay, you have the physical layer. Let me have my pen on. So we have your physical layer over here. Okay, sender and receiver, and you have the other than that, you have all the TCP/IP layer on top of it. Okay, so if you have received any information from sender to receiver on the physical layer, what they will do is that the information will be passed through the upper layer and be processed until it received by the application before can be seen by the user itself. Okay, that is you are on the receiver side lah. On the sender side, it means that whatever the data that you want to transfer, for instance, like I'm doing right now, is through online videos, okay, stream videos. So what it did is that it convert the stream media on the application layer, then pass through all the different layers until to the physical layer, and it will transmit and receive by you guys at your own place, okay, and then it will go through all the upper layer before you can see whatever things that being transferred. Okay, so the focus that we wanted to discuss today is on this transmission medium. Okay, it can be either cable or air. Okay, so that is what we are trying to figure out for today, right? Okay, going through this, okay, we can classify our transmission media much more detailed. Okay, if you look at this slide, this is slide number 6. I jump directly first to slide number 6. Okay, and you have the guided media, where the guided media also can be subdivided into twisted pair cables, coaxial cables, and also fiber optic cables. Okay, so a twisted pair cable is a copper wire that two pairs of cable, then it will twist it together. Okay, and you can basically see that on your Ethernet cable. Then this coaxial cable you can see on your TV medium. Okay, for instance, if you are using kind of what they call it, connection for your TV, so most of it is using a coaxial cable, where you have a single core copper wire at the middle, and then you have the cladding on side of it. Okay, whereas if you are using Unify right now, okay, Unify Home, okay, basically it is based on fiber optics. This is purely on glass medium lah. Then we can also see that we can have this unguided media. Okay, it's a wireless kind of thing. You can have different types of wave. You can have radio wave, microwave, and also infrared. Okay, so we'll look into that later on in details. Okay, uh, I would like to share also on the frequency band. Just jump a bit on some additional slide that I have. Okay, perhaps I can show this part. Okay, so these are the frequency band with respect to the wireless medium. Okay, so you can have what we call wave. Better on this lah. We can have what we call like UHF. Okay, band, VHF, okay, and some other bands that can be used. Okay, so these are some name that they can categorize for the different types of band. Okay, this is considered as high frequency, very high frequency, uh, and so forth. Okay, so these can be classified into that different type of thing. And the frequency band with compared to the wavelength is inversely proportional, meaning that if your frequency band is increasing, okay, from say that from 0 hertz up to 30 picohertz and so forth, okay, your wavelength is actually moving from higher to lower, okay, from 6,000 kilometers to the lowest one, like 1 nanometer and so forth. Okay, and it with respect to this, there are different application that you can see being used. Okay, for instance, on the microwave and the radio frequency band over here, you can see this is where the location of your wireless data 2.4 and 5 gigahertz. Okay, then you have your radio frequency over here, where you have around 800 megahertz up to 2.6 gigahertz. Your 3V broadcast is on this range, and then you have your FM and AM radio basically over here. Okay, so moving from lower frequency to higher frequency. Okay, so you will see that they have different characteristic. Basically, when you have this radio wave radio broadcast or TV broadcast, FM radio broadcast, basically it can penetrate much more, and it can cover much more further distance lah. Then moving to here, where you will have very short distance, like your infrared, okay, being used for your TV controller, for instance, is a very short range. Okay, so that is where you can see the different type of frequency spectrum being deployed lah. Okay. So looking into this guided media, so there are three different types that perhaps you will be familiar or you have seen. Is the twisted pair, the coaxial cable, and optical fiber. So the latest one will be using fiber optics, okay, where if you have a unified connection at your home, basically, or even Maxis fiber, okay, basically you are using fiber optics as your medium of transmission. Okay, just because of this fiber optics, it can have a very far distance, meaning that you don't have to put multiple repeaters, okay, as compared to the twisted cable or coaxial cable, where it can span to some distance before you need to repeat it, the signal, okay, and perhaps you need to boost because between the medium you will have degradation of the signal. So when you have this, okay, you have many repeaters that is not efficient. So by having this latest fiber optics, you can get a further distance without having to include much more repeaters lah. Okay, so this fiber optics basically at the beginning is for what we call back end, okay, or the backbone of all this network. Okay, but now since the price has gone down, so now you can get the fiber to the direct to your home. Okay, so now the term like fiber FTTH, fiber to the home, FTTH. Okay, is where you can see that it is representing the concept of fiber to the home. You can have FTTB, right? FTTB, basically this is fiber to the building, okay? And also you can have fiber to the curb, fiber to any closest medium to the end user lah. Okay, so these are the terms that are being used on fiber optics. Okay, but before that, the one medium that usually being used when you use your Ethernet port, okay, you can see that this Ethernet port basically it can be based on 100 base Ethernet. It can be 1,000 base Ethernet. It can be fast Ethernet, super fast Ethernet, and so forth. Okay, so these are basic twisted pair which consists of two conductors, okay, and being insulated together and being twisted due to some technical reasoning, okay. So to make sure that the interference between those two cables can be reduced, okay. So one of the wires out of the two wires is being used to carry signal, okay, and the other is only used as a ground reference. This is due to that we actually need to identify either 0 or 1 bits, okay. So with respect to that, we just need to identify either you have a value on your signal or you don't have any at all. So with respect to that, you have either 1 or 0. Okay, so you have two levels only that you need to identify. Okay, um, but although you have these two cables, okay, interference or degradation can be affected, okay, both wire, which created unwanted signal, means that it can interfere between those two signal, okay, and the receiver at the end, however, operates on the difference between those unwanted signal, okay. So mention when we mentioned about this, okay, although if we have this kind of signal, okay, say that you have something signal like this, okay, right, okay, when you pass it through your medium of transfer, then perhaps the signal will be degraded and you have lower voltage from the previous input signal. So uh, we just need to know here it says that the difference between the unwanted signal, okay, so because you have reduced the signal strength, okay, but we still can identify, okay, with respect to this, either whatever that above the 0 value here will be considered as 1, the rest will be 0. Okay, so that is the why they need to have the difference. Okay, so if the two wire affected by interference equally, the receiver is immune because the difference is 0. Okay, so you just want to make sure that you get either 0 or 1. Okay, so this is how it looks like. You have a conductor, both twisted cable, and it's being twisted due to some theory of interference. Okay, so you wanted to make sure that it reduced the interference between those two cables. So if the two wires are parallel, the effect of this unwanted signal is not the same in both wire because they are on different location relative to interference sources. And the result in a different at the receiver by twisting the pair, a balance is maintained. So basically, it's to reduce the interference and also to make sure that it's much hardened. Okay. So also there are two different types of twisted cable. One is what we call UTP. Okay, so if you wanted to buy Ethernet cable, basically they will ask you for either you want to have a UTP or STP. So how it looks like is that the basic UTP is that you have the cable and this is just a cover or insulator lah, right? Whereas for SDP, okay, you will have some metal sheet over here, okay, that you can see over here, that covers your twisted pair, and then you have your plastic cover on top of it. Okay, sorry, there's a lorry right now driving. If you can't hear me, okay. I just want to switch back to Google Meet to see if there's any other question so far. Let me just move back. Is there any other question at this moment? Okay. Yours or my slide is not sliding. Let me see. Muhammad Daniel, sorry sir for asking. I'm from TCTL. But got no info about our class. Okay, so this Muhammad Daniel, perhaps you can email me and I can address your lecture TC3L. Okay, I'm glad to say basically I'm at one of the hotel or golf club. Okay, I have a session over here, so I take this opportunity so that we so to share with you lah. Okay. All right. There's no major question. So I want to go back to the slide. Right. Can you see my slide or is it frozen? Let me check. Is it frozen or what? No, right? So it's good, right? Okay. Continue. Right. So when you have the chance to buy this twisted cable, but basically right now you are talking about fiber optics lah. So when you have the chance, if you are being asked to buy perhaps a twisted cable pair, okay, so you have the option either to use UTP or STP. But basically this STP will be much more expensive because you have additional materials, okay, so this would be much more expensive. Okay, I would say that more towards more people use this UTP because it's working and it's not that expensive lah. Okay, and even it says that if you are using this STP, okay, it is much bulkier, okay, and as I mentioned, it's much more expensive. Okay, so more people you can say that more are using UTP rather than STP. Okay, then this is the slide that shows the performance. Basically, what you can see from here is that when the distance or the frequency is higher here, there will be much more attenuation. Okay, so the twisted pair can pass a wide range of frequency, which increasing with increasing frequency. Okay, so you increase the frequency, the attenuation measure in decibel sharply increase with the frequency above 100 kilohertz. Means that you cannot use higher frequency, and it will disturb the signal itself. Okay, and even when you use cables, okay, basically when you are much more further from the sender, you will have a degradation of your signal itself also, right? So you can see this twisted cable pair being used. Okay, you maybe haven't gone through the time where we use digital subscriber line, okay, DSL, okay, and before that, dial up. Have you ever have this kind of a dial up interim time? Okay, so maybe for those international students, maybe due to which country they are from, okay, if they are perhaps from the country that are more advanced in technology, perhaps they did not experience. But if you are coming from some country like perhaps much slower pace of the digital experience, okay. For instance, I know that in some in African country, so they still using kind of dial-up or this digital subscriber line. So if you are in that area, okay, I was in that area when started with with the dial up. So basically, when you have this dial up technology, you can be either having voice or perhaps data. Okay, so you need to choose between those two. So if you are using your voice, you are unable to use the data. Okay, when you use your data, you are unable to use your voice communication lah. So with respect to that, okay, that is where dial up came in lah. So whenever by default it's a voice communication, but when you already have this what they call it data, okay, so your when you need to connect to your data line, so what you have to drop your voice lah. Okay, so it's either or. Okay, so you will have a dial up type of communication lah. And then with digital subscriber line, this is where they started to have both communication line available on in parallel. So now, if your mom trying to call your dad, okay, and in the same time you are trying to scroll on your browser, okay, both can be used parallelly. Okay, so that is where the digital subscriber line happen. Okay, and now moving on, you still have that kind of communication where both data and digital can be used in parallel. Okay, so with twisted cable pair, okay, so you will have where what we call 10 base T, okay, or 100 base T, 1000 base T, okay. So this base T represent the twisted cable pair lah. So when you see this base T, so basically this is a twisted cable pair. Same as when we do our Cisco packet tracer, okay. When you connect to any end user, okay, or any network device, you need to connect the cables, right? So when you try to form the cable, and it will say that choose which interface. Okay, so this is where we mentioned about interface. But in the simulator, it doesn't have this 10 base T, 100 base T. It just say that this is fast Ethernet. Okay, so that is another term lah that we can use. Okay, this is another term that we can use on the physical interface. Okay, so you use 10 base T, 100 base T, and the T represent that this is a twisted pair, right? And other than that, we have also coaxial cable, but basically for data transmission, we barely use this coaxial cable. Okay, this is how it looks like in your coaxial cable, where you have the inner connector. This is usually the copper wire. Okay, and then you have an insulator. Okay, and then you have another conductor outside of the insulator that it been again insulated, and you have a plastic cover. Okay, so this with this coaxial cable, the performance is much better for higher frequency range. Okay, but again, if you remember, with higher frequency range means that the distance will be much or the wavelength will be much more smaller. Okay, compared to the one that we have lower frequency range. Okay, so here it says that this will can be applied on a higher frequency range. Okay. And sometimes they call it coax, coax, where you have the center core conductor of solid wire, then you have the insulating shelf, okay, encased in an outer conductor of metal foil or braid, and a combination of the two or combination of the two. Then you have the outer metallic wrapping serve both as a shielded against noise and as the second conductor. So basically for this coaxial cable or coax, you will see that more towards when you use your media transfer. Okay, for instance, for your audio video television. Okay, so you will see that this is being used. Usually the wire cover is the white wire cover. Okay. Whereas for the coaxial, usually you have the blue one. Okay, so that's the normal use of color lah. So this shows the performance. Again, it will also have a degradation whenever that it goes to higher frequency, and it's much more higher lah for coaxial cable compared to the twisted pair. So basically, coaxial cable is much better for data transmission and for better for the range of communication medium rather than the coaxial cable. Okay, so this coaxial cable, okay, basically it says that here it started with analog television telephone network, okay, but then we say that it's uh, not being fully utilized or not optimized for digital transmission, okay. So later it was used in digital telephone where you have a single coaxial cable to carry digital data up to 600 Mbps, okay. But here it says that coaxial cable in telephone network has largely been replaced today by the fiber optic cable. Okay, so now it's been outclassed by the fiber optics. Okay, so you won't see this much implementation on data transmission medium. Okay, but cable TV, for instance, so you have your what do you call it? Your TV channel, okay, a paid TV channel in Malaysia. So you use this coaxial cable, okay. Plus, right now, if you use the paid TV channel, it's combining with the Ethernet, which using fiber optics, okay. So that is where or you use this cable that communicates between your dish, your satellite dish to your box for your TV medium. Okay, so you use this cable lah. Another common application of the coaxial cable is traditional Ethernet lah. Okay, but again, the copper wire, twisted copper wire is surpass this coaxial cable, right? Better than the coaxial cable. Okay. So now, the most important medium that on this table would be the fiber optics cable lah. Okay, so fiber optics basically is a glass medium, okay, a glass of plastic, okay, where you be having problem if you want to bend it, okay, and you will also need to have a proper connection if you wanted to combine between two fiber optics, okay. But now the process has been getting much better. Before this, if you want to combine two different cables, okay, or you want to join two different cables, because basically if you see copper wire also, when you wanted to extend it, you have some what they call it adapters, or you need to do something to actually interconnect those copper wire. Same as fiber optics, you need to join them, and much more because this is more sensitive to the light transmission, okay, because when you put the light through the fiber optics, it means that you wanted to make it either diffract or bend it, okay. We'll see that later. So what you can see is that with respect to this, you need to align it properly so that you're able to make that transmission proper lah. Okay, so the joint is much more right now being properly or making the faster. Do you have some medium of joining lah right now compared to the previous one where you need to have a very long time to make a joint? Okay, so this is fiber optics. Okay, you use light to travel it, okay, in a straight line as long as moving through a uniform substance. Okay, so if you have a single uniform substance, you can make it move in a straight line, okay. But later you see that you can also have these fiber optics used with the bending and also with the refraction and diffraction, okay. So here is the way where you have the effect where say that you are using your glass over here, then you have your insulator or less than, okay, materials, okay. So based on physics, okay, so if you have going from more dense to less dense, okay, with some specific angle, you will bend it, okay. So the light will be bent, okay, to some critical angle, refraction, okay, and after that it will totally do a reflection, okay. So this is refraction, okay, where the signal is bent, okay. So we call this refraction. Whereas here is totally reflect. Yeah? So it goes from here to here. It should be 90 degrees in order lah, so that you're able. Here it means that you at the critical angle, means that if you show the light at a critical angle to the medium, you will see that the light will bend, but in parallel to the medium of transfer. Okay, so if a ray of light travel through one substance, suddenly enter another or more or less dense, the ray changes direction. Okay, so the refraction is where you say that there's a change of direction. Okay. And note that the critical angle is a property of the substance, okay, based on the substance, what type of substance that you use, okay, so it will with respect to that substance, and its value is different from one substance to another, okay. So this is the concept of fiber optics, okay, but later we'll see that you can have a different type of fiber optics medium, okay. You can have single mode, multi-mode, and so forth, okay. So as mentioned just now, when you have this fiber optics, okay, going from less medium, more dense to less dense, okay, so you will try or you use what we call reflection, okay. So now this is how it looks like if the signal needs to be transferred from your left to your right hand side, okay. So this is your sender, this is your receiver. So you will need to transfer or send your light. Is either if you want to have a straight light, then you can send it directly onto the medium, or you can actually send it through an angle, okay, so that it will reflect at the border of the medium, okay, and eventually received by the receiver, okay. So the receiver will know, okay, if this angle, this is signal number one. So if you have a different signal, okay, let me change my pen color. In color, let me change to green, okay. So if you have a different angle, okay, so now you have a signal that can send on a different angle, okay, and receive at the receiver, and the receiver will actually detect this is a different signal, okay, and so forth, okay. So this is how it looks like when you have multiple signal being sent through this fiber optics, okay. And that's the concept of fiber optics. So the fiber optics, okay, can also be, as I mentioned, the one that we mentioned just now is what we call a single mode, a type of medium, right? And you can also have this what we call multi-mode, okay? And these two modes, single and multi-mode, for propagating light along optical channels, each requiring fiber with different physical characteristics. Multi-mode can be implemented in two, okay? This is what we call two types, step index and gradient index, okay? So step index, it means that you just have your fiber optics, then you have your other, or the other, what do you call it, on the lesser medium, okay. Whereas for gradient index, it means that this is the cross sectional of your fiber optics, eh? So if you have a fiber optics along this way, right, how do I draw this? Okay, so this is your fiber optics. You cut this cross over here, okay, and then you change your angle to the cross sectional. You will see that this is the fiber, and this is your what they call it, the cladding lah. Okay, so cladding. And for gradient index, it means that you will have multiple level of your fiber optics. Okay, so you have one, perhaps two, then you have another one, okay, and so forth. Okay, and later you'll see that this is where you will have a kind of signal that can be bent into much more. So then this you have your clear outside. Okay, so you'll see later on this. Okay, but you will see that this fiber optics, okay, you have single and multi-mode, and this multi-mode can be either step index or graded index. Okay. Okay, so a multi-mode names because multiple beam from a light source move through the one core in different path. Okay, so the one that I've drawn here, this is considered multi-mode. Single mode means that you have only single line using one fiber optics. Okay, but for multi-mode, it means that for your single fiber optics, you can have multiple signal being transferred. So it is much more effective in the sense that you don't have to lay many cables, but you can have just single cable and you can support much user lah. Okay, so the name is because multiple beam from a light source move to the core in different path. Okay, the path depends on the angle of send, and how this beam move within the cable depends on the structure of the core. So this will be decided by the designer. And in multi-mode step in the fiber, the density of the core remain constant from the center of to the edge. Okay, so here when I draw this, the fiber optics here, if it's the diameter here is D, okay, so the diameter over here is D, meaning that the whole fiber optics is on the same density. Okay, compared to here, if you have the diameter here across here to the between all the fiber modes, okay, you will see that the density is being going from higher to lesser on the fiber itself. So here, with multi-mode step in the fiber, it says that the density, okay, remain constant. Yeah? The density remain constant. Okay, and the beam of light move through this constant density in a straight line. Okay, so basically for a multi-mode step index, you have the signal being shunned through a straight line. At the interface, there is an abrupt change to a lower density that alter the angle of the beam motion, and the term step index refers to the suddenness of this change. Okay, so because you need to end up the signal, okay, so you will need to make sure that you address this. Then we also have this multi-mode graded index. Okay, so how do you define this multi-mode graded index? When you have with varying density, okay, and this density is highest at the center of the core and decrease gradually to its lowest at the edge. Okay, so this is the definition of your multi-mode graded index fiber. Okay, single mode basically is a step index fiber and a high focus source of light that limits beam to a small range of angle. Okay, and so forth. Okay, so these are the two different types, okay, of a single mode and graded mode. This diagram basically shows you, okay, the different type of mode. Okay, so the one that we mentioned, this is a multi-mode with a step index. Okay, so you can see that the medium or the fiber is a step index, means that the density is almost the same throughout the core. Okay, whereas multi-mode means that you can have multiple sources. Then this is a multi-mode with a graded index. Okay, this where you have multiple sender, signal of sender with this graded index, and it looks like it's bending, right? It's not reflection. Okay, this one with a step index, you will depend on the technology called reflection. This one it will bend small because it's a graded index, so it will bend bit by bit until it will reach at the core, at the border, and then it will actually reflect. Okay, so but in general, we see that this kind of signal is being bent lah, rather than is reflect on this. Whereas for a single mode, you have a single source with a single medium of transfer. Okay, so that's the difference between it. And if you look at the cable itself, okay, so you have the cladding, the glass or plastic core, okay, and then you have the plastic buffer, and then you have some protection, okay, and then you have the outer jacket, right? So this is on the fiber mode, different mode of fiber. And the performance wise, okay, with different frequency, it almost flat, okay, although you have see that this is where you have different properties out of it, okay, but basically it's almost flat lah, because the range between this is so small compared to the previous one. Okay, so you can use different wavelength to be transferred using this multimode. So the measurement of attenuation versus wavelength shows a very interesting phenomena in fiber optics, where attenuation is flatter than, so flat here means that it's almost flat lah. Okay. In the case of twisted cable pair and coaxial cable, twisted cable pair, they have kind of this, right? Where it increasing with respect to the wavelength, okay, but for this fiber optics almost flat, okay, and the performance is such that we need fewer, actually less than 10 times lesser repeaters, okay. So since we can use further wavelength, means that you can actually transfer it to a very large distance. So with respect to that, you don't need much more repeaters. Okay, so that is why fiber optics is being chosen to be one of the best medium of transfer at this moment. Okay, then when you look at fiber optics medium, usually you define it as FX right now. Okay, so fast Ethernet or X, okay, is a fiber optics. So FX or X represent that this is based on fiber. Okay, so if you look at like a different network device with some interface, so you need to look either is a copper base or fiber base. Okay, so if the medium, so for instance a router or a switch, it has a port of that 100 base FX, it means that you can use the fiber optic cables, or else you will not able to use this fiber optics. Okay, so you need to mesh between your device. Okay, sometimes the device has the interface, so with that respect interface, now you're able to need to use different medium, which is your fiber optics. Okay, so we can now you can get a range up to 1600 Gbps for your fiber optics. Okay, right. Let me switch back to Google Meet if there's any question at this moment. You guys able to hear me? Right? Erfam, Nicholas said it's okay. Yes, right. So maybe some of you, if you're unable to hear me, perhaps you are currently having problem on your device. Okay. All right. Any questions so far? Link of what? For registration, is it? For attendance, I think this will be it. You can use this, the link. Is that answer your question, Nicholas? Okay. So any question before I move on? No, right? Okay. So turning back to my slide. Okay. So now we already see the medium, right? So when you have this guided media, you will use it basically based on, you need to have a very good performance, very high-end performance, okay? Because with this guided media, the interference will be much lesser compared to when we see you use unguided media. The term unguided means this wireless communication. So with fiber optics, usually is secured, not kind of security in the sense that the signal will be much more better lah, because you can send it very far distance, and with respect to that, you don't the signal will be usually having the same the, the the power of it, okay, will have the same between sender and receiver. So it almost maintain lah. Basically, if fiber optics, I can say that it's being protected lah. So the guided means that it is have a physical form, but in the same time you can say that the signal much more better lah compared to unguided media. Okay, but advantage of unguided media, whereas this unguided media is simple, okay, simple, and we can say that for user is inexpensive lah, but for the one that managing it, you need to have some medium, for instance mobile phone, or if you are using Wi-Fi, you need to have either a base station or access point to be the main point of your medium lah. Okay, but the advantage is where you don't need to actually have any cable or medium or physical medium to be connected. That will be one of the advantage when we use unguided media. Okay, so most of the time right now you will see that we communicate either through your data plan, okay, through your mobile phone, or perhaps in the same time you use Wi-Fi lah. So Wi-Fi is a different technology from your mobile technology, but then right now it's already being combined together. Okay, that is why you can have both type of technology on your same medium, either on your phone or on your computer itself. But at one time it's totally separated, or perhaps if you want to combine it at one time also, you need to have some different interface that not being built in. Right now you have your Wi-Fi being built in into your laptop or PC, even on your mobile phone, but at different time backward. Okay, so you will see that you don't have this communication. It's not by default. If you want to have Wi-Fi, you need to have that interface. If you want to have your mobile phone work network, perhaps you need to buy a mobile phone, then you have to put your SIM card and so forth. Okay, so you have to actually appreciate this unguided media process, and also based on the history and perhaps how it came by. So now you can communicate. Say in our class we have 122 students altogether. So if everyone came to classes and everyone wanted to connect to the Wi-Fi network, so you don't see any cables being laid around the classes. Okay, so you see that it's very clean. You just need to have the device and just waiting for it to configure properly lah. Okay, so that is unguided media or wireless advantage compared to the other lah. Okay, but for the operator itself, they have to maintain the access point. Okay, and basically when we have like a wireless or a mobile phone, usually we call this one point failure medium, where if the base station down or the access point down, then you will have totally shut down of your communication. Okay, so that is just some introduction of wireless communication. So unguided media, okay, using electromagnetic wave, okay, without using any physical conductor, so you don't have a physical one. Okay, and this is often called a wireless communication. And this wireless communication actually can be subdivided into radio wave, microwave, and infrared wave. Okay, so the one that we usually use for communication is microwave. So this is a two-way communication. Usually for a radio wave, we use this for broadcasting. Okay, so this is for broadcasting. Okay, so your FM radio broadcasting. Okay, so you understand this. Broadcasting microwave is two-way communication, and the infrared basically you can use it when you have line of sight and it's very close lah. You cannot have very large. Okay, so this range, okay, is the total range of your wireless communication. Okay, so you have the microwave, radio and microwave. Then you have the infrared frequency band, okay, and then the light wave over here, right? Also, you can see further, this is much more towards the application, okay? So you can see that this is the light wave, okay, where you have the ultraviolet, X-ray, and gamma rays, okay? Then you have your visible light, okay? Now, visible light also you can do communication. There's some of our lecturers that actually use this visible light research for data communication. Then you have the infrared, okay, and then the microwave and radio wave, okay, and this is what we call terrestrial wave and so forth, okay. And the term will be showing here, okay, where you have the VHF, UHF, okay. So on your TV, on your mobile phone, they will mention that this is using UHF, VHF, HF, MF, LF, and so forth, okay. With respect to that, this is the wavelength and this is the frequency that being used lah. Okay, so for radio wave, it says here no clear cut lah discrimination between radio wave and microwave. Okay, so both can be combined together. It doesn't have like a proper separation, and it range between 3 kilohertz to 1 gigahertz, okay, for electromagnetic, and then normally called a radio wave, and then wave ranging from 1 to 300 gigahertz are called microwave lah, okay. So the behavior will be somewhat different, okay, and the implementation will be somewhat different, okay. So as for radio waves, usually the implementation more to what we call omnidirection. What does omnidirection means? Okay, so if you have one base station, like you have a radio station, okay, a tower of radio station, then you have your transmitter on top of your radio station. So what it did is that it will kind of circle signal, okay. So the signal will be circled and it will cover a very long distance from the transmitter to some areas of coverage lah. So it means that it moves any way or all the way in circle lah. So if you are located on the right hand side of the base station, you still can receive. If you are on the left hand side, you can receive. If you are on the higher flat, okay, say 20 level of flats, you can still receive it. If you are at the bottom of the floor, also you can receive it, okay. So this term omnidirectional means that it's anyway. You have one base station and then you can send it and everyone can receive it, which are within the coverage of that base station lah, okay. So when an antenna transmit radio wave, they are propagated in all direction. It can be vertically, horizontally, okay. So it doesn't have any restriction. And this means that sending and receive antenna do not have to be aligned, okay. So if you need to have another receiver, okay, say that your radio, it doesn't have to be aligned, okay. And you can see that sometimes you have some blockage. For instance, you can see that you can have like a mountain or some blockage lah, a building and so forth, but you can still get the signal, okay, because one thing is that the frequency that being used, it can reach further, okay, which is the one that using our broadcast lah. So this part lah, where you have a very high frequency, okay, a very low frequency with a larger wavelength, okay. So with respect to that, you can actually move around without any interruption from any medium in the middle lah, okay. So that is for broadcast. And for radio wave, it can travel long distance, okay. So where's my pointer? Let me change back to in color upgrade. So it can travel long distance. This is the characteristic of long wave, okay. And this make radio wave a good candidate for a long distance broadcasting such as AM and FM radio itself lah. So radio wave, practically those of low and medium frequency, can penetrate walls, or basically it can reach much distance, and it can overcome any apa ni, interference or any obstruction. Okay, so this characteristic can be both on advantage and disadvantage, whereby if on the advantage side is that you don't need to have additional devices to replicate or extend. Okay, the disadvantage is that you unable to contain the signal, okay, because anybody can receive it, okay. So it's not safe in the terms of the information lah. So it is an advantage because that, for example, the LM can receive signal inside a building, and it is a disadvantage because we cannot isolate the communication to just inside or outside the building. Okay, so this is to cover for large distance, so we use a radio wave lah. And since the omnidirectional characteristic, okay, it is much more better if we can use what they call it multicasting and broadcasting lah. So multicasting, it means that one to many. Broadcasting, the term itself. So multicasting is one to many, whereas broadcasting is to one to all. Okay, so that's the difference lah. To broadcast means that you can send to all, multicast specific send receiver lah. Okay, so you can have multiple receiver, okay, for multicast and broadcast lah. But there's two different terminology and two different meaning between broadcasting and multicasting. Okay. So AM, FM radio is an example of multicasting. And omnidirectional property has a disadvantage where the radio wave transmit by one antenna are susceptible to interference by another antenna that may send signal using the frequency or band. Okay, so since you can actually cover a very large distance, so there's a possibility that you have a similar implementation close to your implementation. So with respect to that, the same frequency band, same signal, okay, so there's a potential of this what they call it interference. Okay, so there's a different of the signal itself. Okay, so the radio wave is relatively narrow, just 1 gigahertz compared to the microwave band, which is much more broader. Okay, when this band is divided into subband, the sideband also narrow, leading to a low data range of digital communication. Okay, so you have a very narrow band compared to your microwave band. Okay, so the bandwidth represent that the capacity, okay, of the frequency band. Okay, and with respect to that, if you need to divide it, so you have to give much more smaller allocation to any of the subband. Okay, so that's the characteristic of radio wave lah. So application of radio wave, the omnidirectional characteristic of radio wave make them useful for multicast communication such as radio, television, and paging system. Okay, then we also have what we call microwave. Okay, and for microwave, we use a unidirectional. Just now you have omni, this one unidirectional. So with respect to unidirectional, you have to have what we call line of sight. I have this diagram where we see that when there's no obstruction in between the sender and receiver, okay, so this part is where we call line of sight, right? So with line of sight, it means that it's best if you can take this signal to a higher length where you don't have any disruption, perhaps from trees, building, mountains, or whatsoever. Okay, and you have that direct between sender and receiver. Then the inverse of it is what we call non-line of sight. Okay, so with a non-line of sight means that there's an obstruction. Okay, and this for microwave line of sight is this is considered an disadvantage lah. Okay, so this is not being used or not being preferred for a microwave. Then there's another what the term is called non-line of sight. Perhaps you don't need to know this. basically for microwave, the term line of sight means that you need to have uh, free between sender and receiver, no obstruction. Okay, so the term line of sight here, it means that you need to have a line of sight. Okay, although it can be far distant, best if you can have much more nearer, and the signal between the sender and receiver, basically you can see by your own bare eyes lah. Okay, so this means that sending and receiving antenna need to be aligned. Okay, and there's no obstruction. And microwave propagation is line of sight, since the tower with the mounted antenna need to be direct side of each other. Tower that are far apart needs to be very tall. Okay, so that is the characteristic of your microwave. And since perhaps if you want to have a long haul distance communication, you wanted to repeat the signal, so you need to have repeaters. Okay, because you cannot find a very far distant line of sight. So what you need, you need to put it into segment. Okay, so you send from one area to another area, then you stretch it perhaps by fiber optics or physical communication, then you extend it using another part of your wireless transmission. Okay, so you need to have repeater. And another disadvantage is that microwave, it cannot penetrate walls. It means that if you are behind a wall, okay, so there's a possibility that your signal won't be able to reach you lah. Okay, so microwave application, due to the unidirectional properties, okay, either it can be used as one-to-one. One-to-one here doesn't mean that it's one user to one user. It can be also used for one-to-one, but as the backbone. Okay, a backbone means that you are sharing a very high bandwidth signal. Okay, but you can connect between these two endpoint, and that endpoint you can extend to multiple user lah. Okay, but the term one to one, it means that for the medium itself can be transmit between one to one communication. Okay, so one to one needs between the sender and receiver, they are used in cellular phone, satellite network, and wireless LAN. Okay, so this can be part of the application. And the next one is the infrared, okay, signal. The range will be between 300 gigahertz to 4 terahertz, okay, with a wavelength of 1 millimeter to 770 nanometers. So advantage, it can prevent interference between one system and another. Okay, but as we already seen that for infrared, okay, it cannot be used for a long range communication. It's useless for long range communication. Long range useless, because the signal cannot prolong far distance, and also it needs to be line of sight, similar to your microwave. Okay, but this one you will have a very short span. Okay, the usually you use infrared is within a short distance lah. So additionally, we cannot use infrared wave outside a building because the sun ray contain infrared wave that can interfere with the communication. So that's another reason where infrared is not being used widely, especially on the outer definition lah. Okay. So infrared band almost 400 terahertz, okay, but the band will be much greater and has excellent potential for data transmission. Okay, so such band can be used to transmit digital data with a very high rate data. Some manufacturer provide a port called Infrared Data Association (IRDA) to allows a wireless keyboard to communicate with a PC, right? So infrared as a general can be used for a short range, okay, and a close area using line of sight propagation, right? So that is the difference between all these medium, guided and unguided. So with respect to the guided medium, we already seen that what are the advantage and disadvantage of twisted pair. Then we also have looked at the coaxial cable and the application of it. And much widely used right now is the fiber optics, where this can reduce the amount of repeaters because it can go far distance. Okay. Whereas for unguided, you see that a radio wave is considered as a non-line of sight. Okay, you can have anything in middle, but you can still penetrate it. Okay, whereas microwave and infrared is being mentioned as one of the line of sight kind of transmission. Okay, and with respect to that, the infrared is the one that having very wide band, but you need to properly design it for it. Okay, so that would be on lecture 3A. Okay, I would like to move to 3B, but before that, perhaps I need to look into Google Meet if there's any question or any issues. Do you guys have any question or any issue at this moment? Nicholas says, give a thumbs up. Should be okay. There's a raise of hand, is it? Oh no. How do I see a raise of hand? Is there any question or anybody wanted to share anything? Can I move on? Is it okay? All right. So I would like to move on. Okay, since there's no problem or issues. Okay, so the one that we mentioned on the previous discussion based on physical layer lah. Okay, so when you see that all this guided media, right? So this is basically on the physical layer, transmission medium. So basically, you address what would be the medium that needs to be connected to your transfer medium. So you have kind of an interface with some capabilities to get this information to your physical layer. Okay, and then you process it and you pass it to the upper layer. Okay, so in TCP/IP you have all these 5 layers. Okay, so the first is the physical. Now we would like to go a bit onto the data link layer. Okay, so now it's on the data link layer, which is the second bottom of the layer. So the first one is the physical. So now is the data link layer. Okay, so for this slide or for this outcome lecture outcome, okay, we would like to play a bit on the critical role of data link. Explain, okay, the critical role. What are the role of data link to ensure reliable data communication? Reliable data communication over here means that when you send something from sender to receiver, you want to make sure that the information is being received by the receiver. Okay, so that is where you see the term of reliable data communication. To combat reliable data communication, either you need to make sure that you have a lossless medium, or perhaps what you need to do is that you need to recover from whatever losses that you receive lah. Okay, so this is what we call a reliable data communication or reliable data transmission. Okay, this also will have different connotation on the other layer, not just on the physical, not just on data link layer, but on above layer also. There's a possibility that we need to make sure that there's a reliable kind of communication. For instance, in the transport layer where you have the TCP protocol, transport protocol, TCP is the for the reliable data communication. Okay, so you need to also have that kind of reliability on other layers also. Okay, same goes for security. You need to have all the different layer, some component of security. Okay, so that is where we look into later on also. Okay, and analyze the function and responsibility of a data link control protocol. Okay, so there's also what we call data link control protocol that manage the data link layer. understand the principle of governing flow control and error control. Okay, so basically over here we have these two terms that we call flow and error control. For flow control, basically this is for reliable transmission, where if you have signals or information that being lost, how do you combat, how do you uh, recover from any losses? Okay, so there's many types of method. One of it is that you send replication but with a smaller chunk of data that you need, or you can also write resending and so forth. Okay, so it depends on what kind of recovery that you want to have. Okay, whereas flow control is where you need to manage your signal, because whatever it is, when you have your medium of transfer, your own device, okay, you will see that there's some unmatching. For instance, that your Unify, it can go up to 800 Mbps, for instance, okay, but perhaps your device or your interface can only transfer 100 Mbps. That's for instance. Okay, so that unmatching is where you need to do some flow control. Okay, usually when you have a very fast computer, then you have a very low bandwidth or low speed rate, data speed for your medium of transfer. So usually you will have a lot of data being designed or being generated, but it needs to be queued into the medium. Okay, and after sometimes perhaps the medium have to drop because there's also some like kind of storage, okay, buffer, we call it buffer capacity. The buffer has some limit. Okay, so when you generate too many things, too many packets, okay, and while waiting to be transferred to the medium, which is much more slower process, so you need to put it into buffer, but the buffer actually has limitation. So after the buffer has been filled, so all the rest of the data will be lost due to the buffer limitation. Okay, so how do you do that? How do you control? Okay, so some of the method that you can use is that you actually you have to interfere back to the sender, okay, saying that you need to reduce the amount of rate of your packet generated and so forth. Okay, so that's how you look at the flow control. Okay, and then understand the data link layers node. Okay, with the link and services. Concept of data link layer addressing. So for a data link layer addressing, usually we define as a MAC layer, MAC address. Okay, the MAC here, medium access control address, not the MAC as an Apple MAC. Okay, so this is MAC address, not the Apple MAC. Okay, and then explain how address resolution protocol work. Okay, address resolution protocol, it means that when you have to get involved between sender and receiver, you need to make sure that it receive from sender and receiver. And in the current situation where you use what we call IPv4, okay, with IPv4, you aren't able to provide every devices with its own global IP. So that's the limitation, and with respect to that limitation, what we need to do is that we need to have another address, not just the IP address, which is on the internet layer, right? Okay, so IP addressing is on the internet layer. So on the MAC layer, we need to have also define what is our MAC layer. And this MAC address basically is unique to every and each devices, okay, and be controlled by some agencies. So when you have this combination between your MAC address and your IP address, that's where you have to map this. So ARP is the one that actually used to map between the MAC and also the IP address, right? So here we'll look into data link using a scenario, concept of link and nodes. service provided by the data link layer, category of link, and the two sub layers. Okay, so we'll see that on the rest of it. Okay, so also we'll also see on the link layer addressing. Okay, why we need to have this link layer addressing. Okay, then three types of link layer address, and the next one is the ARP. Okay. Okay, so the internet is a combination of network glued together by the connecting devices, router, and switches. If a packet is to travel from a host to another host, it needs to pass through this network. Okay, so this diagram shows how it is being defined when you move from one host to another host. I see that on your notes, perhaps that this line doesn't really inline, okay, with the actual diagram. So I hope that you can draw properly. Okay, so it means that anything on the data link layer, so we are focusing on the data link layer. So the process need to be going to the next node data link layer, being processed, and then move to the next one, and it will touch every data link layer across your network. Okay, so with respect to this, you will see that you have, this is what they call it, end user. Okay, so the end user, one is the sender and one is the receiver, and the rest here is what we call the network device. Okay, and the network device can only go up to 3 layers, okay, which is up to the network layers. So your router, your switch, your hub can only be processed up to this 3 layer. Okay, so they cannot go to the transport and also the application layer. So please note this, okay, so that you're able to understand that if you have a router, if you have a switch, okay, everything is basically on up to the 3 down layer, the data link, network, and also physical, right? So it will process between the data link layer, okay, until it reach to the end, and it will take it on the data layer before it can be processed on the top of it. Okay, so this is how it looks like. On the what they call it, on the ground, you will see something like this, where you can define this as nodes. Okay, so you have all 6 nodes, including your sender, your receiver, okay, and the rest of your switch or your network node. Okay, so in total you have 6 nodes with 5 links. Okay, so this being defined as node, it can be either your end device or your routers. Okay, so with respect to that, you'll be able to define your node and links. And for those who actually needs to do other process, like to determine where how the routing is decided, this concept will be very important, because you will define the link and the nodes, and you have some weightage on the link and nodes in deciding on where to route your packet lah. Okay, so this is on higher level discussion lah. Okay, so you define this. It can be either based on the layering, or you can based on the physical medium. Okay, so with respect to that, this is how it looks like lah. Okay, on the service part, okay, whatever you receive from the above layer is what we call datagram. Okay, and on your data link layer, what you need to do is that you have to encapsulate your datagram with some headers from your data link. Okay, so you see that this diagram, the datagram is being inserted to your what they call here, we call it frame lah. So this frame will consist of your datagram and headers of your data link. Okay, then it will convert to your physical medium. So you send your, what you are sending is digital 1 and 0s. Okay, and then at the intermediate node, okay, switch, router, and so forth, if you need to change the information of your header, okay, this is where you change it. Okay, so the data link information, you can extract the datagram, then you put it onto the next link. Okay, so here it defines the link, different link. This is link 1 and this is link 2, right? So with respect to that, you have the frame type 1 or frame type 2. The term type here is just mentioning that you have a different link. Okay, you don't have to define the type. You can just say that this is a frame from link 1, this is frame for link 2. Okay, so basically the difference between this information on the header will be partly based on where is the link and perhaps what is the MAC address of your receiver lah. Okay, the rest, the datagram, you cannot change at all lah. So it will maintain until the end, right? So when you reach at this datagram or this destination, what you need to do is that you need to drop this header, okay, and then you only pass through the datagram to the upper link. Okay, so that is how it looks like whenever that you have information from the upper layer, that information we call datagram. Then here we have frame. Okay, then for physical we have bits, okay, because it's sending 1 and 0s. Okay, so part of it is to define frame, okay, flow control, error control, and congestion control lah. Okay, so framing, we call it frame because you need to combine between the above information, which is the datagram, and some information that relates to your datagram signal. Okay, so datagram, data link layer at each node needs to encapsulate the datagram from the upper layer in a frame before sending it to the nodes, and the nodes need to be decapsulated the datagram from the frame received on the logical channel. Encapsulated here means that you have to include your datagram into your frame, which the frame also consists information about the data link layer lah. Okay. Then you have the flow control. Here it says that sending data link layer at the end of the link is a produce of frame, and receiving data link layer at the end of the link is a consumer. If the rate of produce frame, so here is where I mentioned just now at the beginning that your sender perhaps can generate much more faster from your medium. And here it says that if the rate of the produce frame is higher, means that you generate much greater than the one that the consumer frame needs to have. Frame at the receiving end needs to be buffer while waiting to be consumed. So you need to implement a buffer, okay, but again due to the limitation of your devices, okay, so your buffer need to have a limit. Okay, you cannot have an unlimited buffer. Different data link layer protocol use different strategies of flow. Drop the frame if the buffer is full, okay, is one of the method that you can use, or send a feedback to the sending data link layer to stop or slow down. Okay, so you can actually use either of these, or perhaps you can combine both it. Okay, means that you have to indicate to the sender either they need to stop or make a slow generator. And in the same time, when you reach the receiver, the information reach the receiver with high buffer rate, okay, so you can drop it, okay, and when you drop it for a reliable one, you have to retransmit. Okay, so then you goes to error control. So usually the flow and error control is being combined together. Okay, so at the sending node, a frame needs to be changed to bits, transformed to electromagnetic signal, and transmit through transmission medium. At the receiving node, electromagnetic signal are received, transport into bit, and create a frame. And since electromagnetic signal are prone to error, frame is also prone to error. Okay, so error here means that your message did not reach the receiver correctly lah. It can be either it's being changed or perhaps it doesn't receive at all. Okay, so error needs to be detected. Okay, so the term here for error control is need to detect, and not just detect but make correction. Okay, detect and correct will be the purpose of this error control. So at the receiver node, and discarded and retransmit by the sending node, right? And with respect to the flow control, you need to also have what we call a congestion control. Link may be congested with frame, which may result in a frame loss. Okay, so basically although you can indicate or you can reply back to the sender, between sender and receiver, but in real world you don't just have one sender, one receiver. Okay, you have many sender and many receiver. With respect to that, you need to have much more generic kind of control on the congestion, whereby more messages in between the nodes, okay, in the middle of the node. So with respect to this, you have to find out how do you want to make sure that there's no congestion. Okay, so you can indicate between sender and receiver, but in the between of your network, you need to have what we call a congestion control. Okay. For the data link layers, okay, it have two different categories, what we call point-to-point link and broadcast link. Okay, and there's two sub layers that being defined, what we call DLC control, data link control sub layer, or media access control sub layer. Okay, so with respect to that, on data link layer, there are two different types. For a broadcast link, it defines both the data link and the sub-control, data link sub-control and media access. But for point-to-point, it just defines the data link control sub-layer. So media access control is where you need to have to share the media for multiple user. Okay. But if you have a single user, that's why you don't have any of this media access control if you have a point-to-point communication. Okay, so that's what it represents in this diagram. Okay. So far, any question? I move to back to Meet. Do you have any question or anything that you wanted to ask? No? All right. Let's go on, okay, and hope to finish before 12, okay. So moving back to my slide, okay. So on a data link layer, let me, okay. So in a link layer addressing, what we can see is that it defines this MAC address. Why we need this MAC address? As mentioned, for IP before, the address is not enough to give to each and every devices. Okay, so what we are looking right now is that on different devices, like small devices at this time round, okay, they wanted to have the kind of smart, it can be smart home, smart city, or smart country, or whatsoever, where the term smart, it means that all these different devices can be managed through internet. Okay, so you have the term internet of thing and so forth. So every and each of these small devices, it can be your phone, it can be your right now your watch itself. Okay, it can be your television, it can be your washing machine, it can be your microwave and so forth. So each and every even your aircon, each and every small item here, the idealist is that they each will have this their own IP address lah. So with this own IP address, you can communicate to your central control, okay, and eventually you can control all this. It means that, for instance, for a smart home, okay, if your aircon has this IP address, so you can have a control on your mobile phone to switch it on or off. Okay, if your CCTV has this IP address, what you can see is that your communication or your control can actually zoom, or perhaps can turn on or off, okay, or mode put into infrared mode, so that you're able to see it remotely. Okay, so but IP before doesn't actually have that. Okay, so with that, you need to have additional address. Okay, so that is where you need to combine it with another addressing that we call link layer addressing. So an internet network such as internet, we cannot make a datagram reach its destination only with IP address. You need to combine with the data link addressing. The source and destination IP address defines the two ends but cannot define which link the packet should go pass through. Okay, so you can with the IP address you can know the sender and receiver, the end to end. But in between is where the question mark will be. Okay, so you have to actually patch this by having this data link layer addressing, right? So if you have this user Alice and Bob, where Alice have this IP address N1, okay, and IP for link. Bob have an IP address of N8, okay. It will also have a link layer address of L1, okay, and also L8 over here, okay. So how do you want to make sure that this information can reach Bob from Alice, okay, where you have all these intermediate devices and different type of link. So this is where the data link needs to perform, okay. So you can see that on the frame itself, you have both. You know that this frame intended from Alice, which L1 IP address, okay, to Bob with the N1 is the IP address for from Alice, okay. You want to send to N8 for Bob, okay. But in between here, you only know that you need to connect to L2 is the link, okay. So in the frame, you know that to go from Alice to Bob, on the data link on your first link is that you have both the sender and receiver on the IP network, IP addressing, and also the link. Okay, so L1 will be connected to L2. So you know now you have to send this packet or this frame from link number 1 to link number 2. Okay, so then you came across a router, and due to some knowledge of the router, okay, so you know that if the router knows that if you want to go through Bob, actually you need to go pass through link 4. So here the frame, what you need to do is that you have to make sure that the frame sending from N3 from N2 to N4, okay, and then and N4 to N5 and so forth. So basically on every link, the data link layer addressing is being changed, okay, and eventually it is the receiver Bob, where your receivers identified that the network addressing is still maintained throughout the communication, but now your frame is where you connect L7 with L8. Okay, so this is the data link that has been changed throughout the communication. Okay, so that is how it looks like lah. Okay. For the data link address, okay, there are 3 different types. One is what we call unicast address, okay, one-to-one communication. Then you have a multicast address, one to many, and a broadcast address where you have one to all. Okay, so basically the difference between one to many and one to all, basically what we can say is that for broadcast means that you are able to choose lah. When the sender send, it will send to all. Okay. For instance, emergency information can be passed through SMS, so everyone can receive it, no matter you are who are you lah. So you will receive it. One to many basically is where you choose the receiver, many receiver. You have to choose many receiver and then you send it once to that many receiver. Okay, so that's the difference between broadcast and multicast. Okay, so in MAC address, okay, it defines 48 bits or 6 byte in hexadecimal. Okay, So you have the 48 bits. So this is totally 48 bits. Okay. And actually you have 12 hexadecimal. So you have 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 hexadecimal, 4 bits or 6 byte, and it's being separated by a semicolon. Okay, so this is your what they call it, your link layer address. But for unicast, there's a specific characteristic. The second digit need to be an even number. So the second one need to be even, means that 2, 4, 8, 6, 10, then you don't have 10 for hexadecimal. It's A, then C, C, F lah, right? So for even here, so if you get this, you will say that this is a unicast address. Then if you have an odd number over here, so you will say that this is a multicast address. Okay, so even you have, it's a unicast. If it's odd numbers, it's a multicast. Then if you have all ones, okay, so FFFFF is actually all ones. Okay, so if you have all ones for all the 48 bits, so this is called a broadcast address. Okay, so that's the difference. So even is a unicast, odd is multicast, all one is the broadcast address, right? Okay, so this is the example, 6 byte, 12 hexa digits, 48 bits, right? Then you can also see that if the last byte of your frame is 0, okay, is unicast. If this is 1, is a multicast, right? So the list unique bit for your first byte define the type of address, and if bit is 0, then the address is unicast, or otherwise is a multicast. And for broadcast is where you have all ones. So broadcast have all ones. Okay. So I want you to take 2 minutes to identify what would be the answer for this. Okay. For A, you have 4A, 30, 10, 21, 10, 1A. So what would be the address, or what would be the type? Okay, is it unicast or multicast? Is it a broadcast? Then B, you also have you will have 47, 20, 1B, 2E, 08, EE, and then you have FFFF. Okay, so try this first. Without looking at the answer, I know that you have the answer. Without looking at the answer, can you identify it? Okay? You guys able to identify it? So I hope that you're able to identify it. So basically, for A, is a unicast, because it's a even. Okay, so binary is 1 0. Okay, unicast address because A is binary of 1 0 1 0. Okay, and then B, the second bit is the second byte is actually odd, so is a multicast. Then the last one is actually broadcast, right? Okay, so show how the address is sent out. Okay, so here it says that the address is sent left to right. So from your left to right, byte by byte, and each byte is sent right to left, bit by bit as shown. Okay. Okay, and last but not least, okay, the term ARP, basically it's is on the network layer, but help to address to the link layer addressing. Okay, so of your IP address, this ARP will actually help you to resolve the addressing, okay, on the link layer. So anytime a node has an IP address to be sent to another link node, it has an IP address to the receiver node. Okay, However, the IP address of the next node is not helpful, okay, because the IP address is not what we call it, it's not global, okay, it's not helpful, okay. So moving a frame to the link, we need the link layer address of the next node, and this in the time when the ARP becomes helpful. So ARP stands for Address Resolution Protocol, and ASP accepts an IP address from the IP protocol, maps the address to the corresponding link layer address, and pass it to the data link layer. Okay, so basically, it has a table of mapping in between the IP address and the MAC. Okay, because sometimes your IP address would be the same for a few PCs, okay, or few end user, but the MAC address will be some kind of different. Okay, so how it perform basically is that if you have a request, then you will actually broadcast to everyone looking for this node. Okay, then when the user or the receiver receive the information and it's intended for him or her, it will reply, I am the node and my link address is L2. Okay, so with that, it will put into the address table mapping between the MAC and IP address. Okay, so this is the packet for ARP. Okay, so you have the hardware type, the protocol type, hardware length, protocol length. This is where you request and reply. So the request and reply, this is when you have the request. Okay, so this is the request is one to hear the information on the header is one. Here the information of the header is two. So here operation is one or two. You have the source hardware address, you have the source protocol address, destination hardware address, and destination protocol address. Okay, so all this information will be needed to be matched. Okay? So so this is an example. Okay, so you can look into it. Okay, and with respect to that, you will see that it actually perform the combined table between the IP address and also the MAC address, right? So before to conclude for this part is that we have seen that a data link service where it needs to have this formatting, frame formatting, okay, within it you will need to have a flow control, error control, and congestion control. Okay, then we also see that for the link layer addressing, you need to have this unicast, multicast, or broadcast. Unicast where you define is an odd on the second byte. Okay, and multicast you have an even on the second byte, and broadcast when you have all ones. Okay, and then it's not enough to just have the IP address, so you need to have this table of match addressing between your IP and your MAC address. So ARP will actually help you to do that. Okay. Uh, so I open if you guys have any question or anything that you wanted to ask. Can I have the attendance link? Yeah, I think it's already been checked multiple times, right? I hope this helped you. So question, if you have any question or any concern or anything. So for next week, okay, those who have tutorial or labs with me, we will resume as usual, okay. But we will need to make it much faster compared to the past week, lah, right? So open to any question or anything that you want to address. Do you have anything? Are you still with me? You guys will still with me or not? No thumbs up, no one comment. Do we have quiz next week? Yes, we will have quiz. Okay, so have a lot of thumbs up, meaning that you still have you are still with me. Question: Lim Se Wen Yuan, what's do you have any question? Uh, Online or physical? It should be online. what are the quiz about? You can see the what they call it, the academic planner. Okay, basically it covers chapter 1 until chapter 3, if not mistaken lah. Do we have final exam? No. You can check on the course structure. What is the quiz about? It's about chapter 1 until chapter 3. Okay. Why of what? Why? Ahmad Zakon, why? When? Day. Day will be during lecture lah. Why? Ahmad Zakwan, you ask why? MCQ. Yeah, it's MCQ. MCQ. Is it hard? Nah. If you focus on my lecture, I think you should be okay. Can you make a detailed announcement on Google Meet? Okay, sure. How many questions? Not more than 15 lah. All right. Anything else? Oh, thumbs up eh? Okay. I will stop recording. Stop recording.